Hi there. For this video, we'll be discussing the zero fraction method in solving rational equations. So if we have a polynomial a over a polynomial b, and this one is equal to 0, provided that b is not equal to 0, when will this equality hold? This equality will hold if a is equal to 0. Indeed, any rational expression with a numerator of 0 and a denominator of to be non-zero, the outcome is 0. So this is the basic idea in the zero fraction method. Note that this is useful if the rational expressions in our equation have a denominator that we can easily make the same. Let's start with this basic example. Let's have 3x over 4 equals x plus 1 over 2. Similar to how we usually solve a rational equation like in the previous video or the previous method, what we first do is determine its domain. Since the denominators here will never be 0, we can conclude that the domain for this one is all real numbers. So there are no exceptions, so any value of x that we get is a possible solution to this equation. So the first step in applying the zero fraction method is to moving every rational expression to one side of the equation. So for this case, we move this one to the left to obtain 3x over 4 minus x plus 1 over 2 equals 0. And from here, our goal is to make the denominators the same. So what we can do is we can multiply 2 over 2 out here. By multiplying 2 over 2, this one out here becomes 4. So they are already rational expressions with similar denominators. So this one will be in the denominator we'll have 4, and in the numerator we'll have 3x minus x plus 1 times 2 equals 0. Let's move this one first. Now, for this equation to hold, by applying the zero fraction method, we know that the numerator must be equal to 0. So we've got 3x, simplifying the numerator, we've got x plus 1 times 2 is 2x plus 2 equals 0. Distributing the negative out here, we'll obtain 3x minus 2x minus 2 equals 0. This will become x minus 2 equals 0, or simply x equals 2. This one out here is the final answer. Let's go on to our second example. Let's have x plus 1 over x equals 3 over 2x. Again, the first step is to determine the domain of these expressions. So by looking at the denominators, when will these denominators be equal to 0? Well, if we have x equals 0 or 2x equals 0. In any case, it is simply x equals 0, since 2x equals 0 also implies x equals 0. So with that, we know that the domain for this one is all real numbers except 0. So if we obtain 0 later, that one is not part of the solution. So applying the zero fraction method, first we move this one to the left side to obtain x plus 1 over x minus 3 over 2x equals 0. And again, the goal is to make the denominators the same. So we multiply what out here? We multiply 2 over 2 to make the denominators the same. So we'll have here x plus 1 times 2 minus 3 all over, the denominator now is 2x equals 0. For this equality to hold, by the zero fraction method, this numerator must be equal to 0. So we've got here, simplifying the numerator, we'll have 2x plus 2 minus 3 equals 0. Simplifying further, we can add this one up to obtain 2x. That should be negative 1 equals 0. Or simply 2x equals 1. Or finally, we've got x equals 1/2. And this one out here is the final answer. Observe that our solution, which is x equals 1/2, is part of the domain out here, since 1/2 is part of all real numbers excluding 0. Let's have this third example. Let's have 2a minus 4 over a minus 1 equals 5 over a plus 1/2. To solve this one, again, we first check the domain. So observing the denominators out here, when will these denominators be equal to 0? If we have a minus 1 equals 0, a equals 0, or 2 equals 0. But 2 equals 0 can never happen. So we remove that case. For a minus 1, this simplifies to a equals 1. So from here, we know that the domain now is all real numbers except 0 and 1. So when we obtain 0 and 1, that won't be part of our solution. Just move this on out here. And so the first step again is to move everything to the left side. So we've got 2a minus 4 over a minus 1 minus 5 over a. Oops, this should be negative 1/2 equals 0. Now, we make the denominators the same. Since there are no common factors among a minus 1, a, and 2, we'll multiply, for instance, the 2 of this to this rational expression. So it would go like this. We'll multiply 2a over 2a out here. For this next one, we'll multiply, we don't have a minus 1 and 2. So we multiply 2 and a minus 1, or simply that's 2a minus 2, 2a minus 2. And lastly, we multiply a times a minus 1 over a times a minus 1 here, or simply a squared minus a. So how did we obtain that? Well, you may check my video on adding and subtracting rational expressions, which simply states that if we have rational expressions with different denominators and there are no common factors in it, or even there are common factors in it, the key is to multiply the LCM. Or, not necessarily multiply the LCM, but make the denominator the LCM of the whole denominators out there. So if that's quite confusing, you may check out my video on that, which I will probably link around in this video. So simplifying this, we'll have in the numerator 2a minus 4 times 2a will be 4a squared minus 8a. Then we've got this portion out here, negative 5 times 2a minus 2. That will give us negative 10a plus 10. Lastly, we have here negative 1 times a squared minus a. That will give us negative a squared plus 8. All over, we've got a minus 1, 2a, and what else? Yeah, that's it. Let's just split this up. A minus 1, a, and 2. This one is equal to 0. And this one is the beautiful part in the zero fraction method, since we don't really need to simplify this denominator anymore. We just need to focus on this one. So let's clear out some space out here. And so we'll have, can disregard the denominator, and we'll have this one out here. Simplifying this expression, we've got 4a squared minus a squared. That will give us 3a squared, negative 8a minus 10a plus a. That will give us negative 7a, and the 10 out here. This one is equal to 0. Now, as you can observe, what we have is a quadratic equation. So you can verify that this one factors into 3a minus 2 and a minus 5. So how to do that? You can verify that by checking out my factoring quadratic equations video. So there are 3 methods. We can use factoring, we can use completing the square, or we can use the quadratic formula. But for this one, I think the best option is using the factoring method, since it's straightforward. So from here, we can conclude that the two possible values are either 3a minus 2 equals 0, that would give us a equals 2 over 3, or we have a minus 5 equals 0, or that would give us a equals 5. Since these two are part of our domain out here, we conclude that these two are the actual answers for this equation. So that's the answer for this one. Let's just have one final example to showcase the beauty in using this zero fraction method as compared to the cross multiplication method. If we have u plus 3 over u minus 4 equals u squared minus 1 over u cubed minus 3u minus 4. Note that if we apply the cross multiplication method out here and multiply this 2 and multiply this 2, that would be very large. This should be 2. That would be a very large outcome, since we'll have a polynomial of degree 3. So we'll try to apply the zero fraction method. So the first step is to check the domain. So checking the domain, we've got u minus 4 equals to 0. That will give us u equals 4. For this next one, we've got u squared minus 3u minus 4 equals 0. Note that u squared minus 3u minus 4 factors into u minus 4 and u plus 1. Let's fix this one to avoid confusion. U minus 4. There. Now, from here, we know that this would give us u equals 4 and u equals -1. So I skipped a process out there. Take note of that one. And so, we can therefore conclude that the domain for this one is all real numbers except -1 and 4. Let's move this one out of here. And let's now start the solution process for this one. First, we move this one to the left side. So we'll obtain u plus 3 over u minus 4 minus u squared minus 1 over u squared minus 3u minus 4. And to be clearer, let's factor this one out. From a while ago, we know that its factored form is u minus 4 and u plus 1. Since we have a common factor of u minus 4 out here, we'll simply need to multiply u plus 1 over u plus 1 out here. And so we'll have first u plus 3 times u plus 1 by FOIL method. That would give us u squared plus u plus 3u plus 3. Then we've got this one out here. That will give us negative u squared minus 1 over u minus 4 times u plus 1 equals 0. So with this, we can now apply the zero fraction method, which states that for this to be true, this one out here must be equal to 0. So we've got, simplifying this, we have u squared plus 4u plus 3 minus u squared plus 1 equals 0. So I distributed the negative sign out here. And then from here, we can cancel out some common terms. So we've got u squared out here, and we simplify this. So we've got 4u plus 3 plus 1 is 4. This would give us 4u equals negative 4, or simply u equals negative 1. The question is this the answer for this problem? Note that u equals negative 1 is not part of the domain. See, we excluded negative 1 out here, since that would make the equation that we have above to be undefined. Therefore, we can't consider u equals negative 1 out here. It is extraneous, and thus the solution for this one is no real solution. So that is the answer for this one. So that is the importance of the domain. So take note of that one, and yeah, I hope you enjoyed this video. Feel free to comment down below any comments, suggestions, and recommendations that you have for this. So that's it, and that's all for this video.